So let's look at another example involving relative extrema. So let's say I want you to find the relative extrema of the function x squared y squared. So again, we start by finding our critical points. For that, we need our partial derivatives. So here I get 2xy squared, and fy will be 2x squared y. These are polynomials, so they're always defined. So then I look here at my system of equations. Here's my system of equations. So these are going to be true when either x equals 0 or y equals 0. Well, if we're talking about x equals 0, we're looking along, this corresponds to the y-axis. So I'm looking at the points of the form 0, a, where a is any real number. And if I'm looking at y equals 0, we're talking about the x-axis, which means I'm looking at points b, 0. So these are going to be my critical points. So I actually have an infinite number of critical points. The entire x-axis and the entire y-axis are critical points. So now let's look at our second partial derivatives. Take the derivative with respect to x, you'll get 2y squared. Take fx and then take the derivative with respect to y, you'll get 4xy. And lastly, fyy will be 2x squared. So now we want to use the second partials test here. So I need to look at the d, the value d. So let's plug in here. What's fxx? It's 2y squared times 2x squared minus 4xy squared. D will be 4x squared y squared minus 16x squared y squared. So D will be negative 12x squared y squared. So when x and y are both 0, so when D would be 0, so what this means is that our second partials test fails. Because remember that the second partials test, if D is 0, and for all of my critical points, D is 0, the test is inconclusive. Well, what we're going to do is we're going to look at our function, x squared y squared. If I look along the x-axis or the y-axis, this function is going to be 0 because either x is 0 or y is 0. but I know, but otherwise this function will be positive for all other points. And so what this is telling me is that my critical points correspond to minimums. The minimum value of my function is 0. Otherwise, it spits out something bigger than 0. So here I'll say that my critical points, which remember, they're all the points on the x and y axis, my critical points correspond to absolute minimums, not just relative minimums, but absolute minimums. So if your second derivative or your second partials test fails, you need to use information about your function to determine if your critical points are minimums, maximums, or are they relative extrema.